All right. Well, thank you all for being here. I'm super excited you stuck around until a little later. I think it's kind of nice. The place here's got the lights coming up. It's a cool venue, isn't it? So my name is Michael. As I was introduced to Run the Talk Python to Me podcast, that's probably the way you may know me if you know me. I'm a big fan of Python types, and I'm looking forward to sharing some ideas about them with you today. Some of these ideas will be for like, hey, what are these again? Remind me. And some of those, even if you've been working with it for years, hopefully, you're like, wow, I didn't know that was possible. That is awesome. So I'm trying to get something for everyone here. One of the questions people may ask is, will I be able to download this code? Yes. Yes, you will. I'll give you 1 second to take a picture of that. And while you are, I just want to point out that Joe, the guy who gave the fabulous talk, mad props, Joe, about I just wrote this 48 hours ago, and let me show it off. He was on the Talk Python this summer, and we had a really nice chat about a lot of the ideas he talked about. So if you're into what he talked about, be sure to check that out and download the code here if you want. Okay. So let's think about the Python language. We're here for that, right? We like Python. So why not go to Wikipedia? What does Wikipedia tell us about it? Well, zoom in. It's really the second paragraph that's germane to this conversation, but Python is a high-level, general-purpose programming language. Its design philosophy is weird in that it emphasizes readability with the significant use of white space, which at first is weird, but is actually awesome. It's kind of like not quite a what. But the second part is Python is dynamically typed and garbage collected and other things. And there's a little sidebar if we zoom in on it about typing in particular in Wikipedia. Didn't know they had a typing sidebar, but they do. And here it says something about ducks. Python is a duck-typed language. It's also dynamic and strongly typed. Who knew those could go together? It can be gradually applied, but it's ignored. Okay, so we got a lot to talk about here. And it's going to start with our duck, our friend the duck here, duck typing. And well, what is the deal with this duck typing? If you can use the code in a way, if it walks like a duck, quacks like a duck, talks like a duck, it probably is a duck. And Python for a long time subscribed that to how you declare types. If you can use it here, it probably is one of them, and that's good enough, right? But as Python was adopted by larger organizations to build even larger applications, having a little more structure there might help. If you have a team of 1,000 people working on a project, you might want a little extra enforcement on what you said goes into that slot rather than, hey, it's a duck, it's probably cool. So let's think this through for just a second. You all are familiar with Python, so this is the way it's been for a long, long time. Nothing super exciting, but just as a thought experiment. So we're going to try to you see motorcycles. That's a theme that I put into this talk here. So we have a motorcycle, and we want to create one of them here. So we have a constructor, a dunder init, and it takes 4 things. They're in blue. It takes a model, a style, an engine size, and an off-road capability, I guess. I don't know, whatever that is. It has this simpler one called Create Adventure, which is a type of motorcycle. And you don't have to specify the type because that's the type in the name. But just look at this. If somebody said, here's the code, what do you want to do with it? How do you use it? Well, model, I think that might be a string. That's the name. Is that what I put there? Probably. I'll go check the unit test. No unit test. Fabulous. Let me check the docs. No docs. Really. It just says the signature. It doesn't say what they are. Okay. So we'll go with that. So let's try to find some use cases here. Well, we found this use case where they're calling this Create Adventure, and sure enough, they're passing in a string for the model and a number for the engine size. Could it be a float, or does it have to be an integer? Is there a partial CC you can have for motorcycle? I actually don't know. The code doesn't tell you either. We don't know. No one knows. If you run it, you put a 410.1 in there and see if it crashes. I don't know. Right. So at the beginning of this talk, I just want to kind of set the stage, set the spectrum, and give you a sense of where things are. And I don't want you to leave thinking, oh, Michael said I should use types. Types always make it better. Sometimes they make it worse. A lot of times they make it worse. but there are times that may make it awesome. So we have the spectrum, and on the spectrum, on the right-hand side is like more type strict, and on the left-hand side is more YOLO. So we have C++, not on the far right, but if you've done C++, you know there's a lot of symbols, and many of the symbols have to do with typing, like avoid star star, so that got to mean something. So it's over there, but on the other hand, maybe we have JavaScript. Like JavaScript, I don't know if you all seen the Gary Bernhardt talk about Watt. He gave at PyCon, it was amazing. And most of it was to do with JavaScript and its types. So you can take things like, I could have a list and add it to an object. What does that mean? It works. There's not even runtime checking. Python has a dynamic language, but if you try to take even a string and an int and add them, it'll go, no, 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 no. Those are the wrong types. Oh, you do know about types, Python. Interesting. So Python lives not quite over there. We have maybe C# and Swift I would put as more type strict than C++. For example, in C#, you can't just test some expression that's not 0. You have to test a Boolean object. And you can express types can be null or nullable or not. Whereas C++ is just like, yeah, let's go. And Swift is even more so like that, where even reference types, pointers, cannot be nullable unless you explicitly set that. So Python, circa 2014, I would say, lives around here. Now, there are efforts to move some of these popular but less structured languages over. For example, Anders Heilsberg and team came up with TypeScript. And TypeScript is an interesting, sorry, this keeps falling off. TypeScript's an interesting thing where it's like a superset of JavaScript, but it compiles in order to run. You can't run it directly. So you compile it to JavaScript, and then it kind of loses all that behavior and all that knowledge of its types. And if you get it wrong even a little bit, like one type is mismatched, it won't compile, therefore you can't run it. So in this sense, it's quite strict. Not necessarily in a positive way, but it is quite strict. In Python, we're trying to move it that way when you want it to. And that's really the point of this talk, okay? So one of the things that I think is interesting to start this conversation with is like, what is possible because of Python types? There was actually a PEP to try to optimize type, when you express the types in the code, how to make that more efficient than actually doing extra imports. That broke some of these frameworks and was like actually, I think, rolled back or unaccepted. There was a little bit of drama about this, but it passed. And so what frameworks are possible because of this? Well, we heard about Pydantic earlier. Pydantic is awesome stuff. Primo. And really, really good. I love Pydantic, and it's possible because of Python types. That's how you just create a class, you say what types it has, and it just magically goes, I got you. FastAPI largely built upon Pydantic, and Beanie as well. Beanie is basically asynchronous MongoDB plus Pydantic, right? And I did an interesting, I was just curious, like how much Beanie, since our websites, our web apps and APIs are powered by Beanie, I'm like, how much Beanie do we do? Well, we do about 10 terabytes of Beanie a month, about 10 terabytes of JSON through Pydantic through Beanie a month from what I can tell off of our network traffic. Lightstar, I don't know if you're familiar with Lightstar. It's very interesting and very flexible. It's one of the newer web frameworks that's come along. It's kind of like if you kind of like FastAPI and you kind of like Django, but you wanted something in the middle. Lightstar, very interesting. It's pretty new and worth checking out. Also based on top of Starlet, well, originally was based on top of Starlet like FastAPI. If you do like Django, then Django Ninja is also awesome because it's basically Pydantic plus Django and async. There's actually a whole list, an awesome list, because awesome lists are awesome. I love these things. So awesome Python typing, you can check that out. And this just touches on it, right? Okay, so first of all, let's compare some languages here. Let's just see what typing gives us, what it takes away. So first of all, we got our no types motorcycle here. This is the one I kind of showed you before, but with real code. And you can sort of see a little bit more what's happening. It's expanded, so we're just saving these variables. All right, that's interesting. But for example, again, even looking at the code, can this be a float? I have no idea if it can be a float, I really don't. I mean, it just flows to here, and you got to trace on where it's used, right? So it would be nice if that was important, if we could express that, right? It would be nice to know that this thing is a property. There's actually a Boolean, right? Rather than just, hey, it's a property. Have fun with that. And so on, right? That this creates a motorcycle class. But do notice and do admire the cleanliness, the lack of symbols, and just the ability to read this. Not necessarily the ability to understand it, but the ability to read it, okay? The Python type version, I went in through and said, hey, let's go ahead and do a little enumeration for the type of it, just so we have a little more structure here. And because the fonts are big, we can wrap that a little. Right? Now we know, okay, the engine size has to be an int, at least according to this code, right? And so on. And that this property down here can jump is a bool. And it gives us really cool capabilities, right? If I have some kind of motorcycle, and I don't care if it really likes that or not, and I go to can jump, right? Notice it says it's int because that's how the Booleans come through, but really it knows, right? This is the Boolean, right? You can see at the bottom, the top part's a warning I'm doing it wrong. The bottom part says bool, right? So it's really cool that we could just go here. And one of the things about Python that drives me absolutely mad is when I go try to use some new library or some function and it says, oh, this is super flexible. All you got to do is pass whatever you want. It's star arg, star star, kw args. You're like, no, what do I do with this? This tells me nothing. So then you're like, I know I want to do something here. So you go maybe go to source, which is cool. You can do that in Python. So you go to source and you look and maybe there'll be some documentation, but none of them list the one thing you want. So then you go to the real docs and actually over there it shows a usage case, right? Just having this lack of structure of knowing what to do is painful. So having your editor know means you don't have to go to the docs. You don't have to go read someone else's source. It's just right there, like it takes a string. Awesome, let's put that string in there, let's go. All right, so compare this to, let's go back into the no type version for a minute and look at maybe the biggest difference here is if we look at the C# version. All right, let's hide the sidebar so we can see it more. There's a lot of symbols on that page, right? There's a lot of stuff going on. And if you compare these, they're surprisingly similar, actually, right? Like if you knew one, you could kind of know the other. You might wonder what that is. Why there's a private set, I don't know what that is. No, I do know what that is, but it is odd. But there's a lot of stuff on this page, right? A lot of stuff. And it's required. It's not gradual, and it's certainly not ignored, right? So pretty interesting here. And then I guess I'll throw one more out there for you. You can look at the TypeScript one. The TypeScript one looks surprisingly like regular Python, like the typed Python. But if you compile it, is that what you call it? Transpile it? You get something that doesn't look like anything anybody should look at, right? It turns into these ifs, this immediately invoked function to create a class, which you can then use like, whoa. All right, glad we don't have to write that. Like object-oriented JavaScript's weird. All right, so there's some examples of what typing in these different languages look like, and I think of all of them, Python looks actually pretty clean and pure, even in the typed version. So in this talk, at least in the title, I have promised you 5 amazing things. I get to be the judge of whether they're amazing, so hopefully you also find them amazing. So I just showed you kind of like a tiny little bit of what editors can help you with, but let's go look at this here. So I've got this library called lib, and it calls a function called lib2, and about some live refactoring, because that's supposed to be do lib2 things. So it takes a couple of functions here, and if we go, we can even actually ask. PyCharm will say, this is an int, and this is a string. And because these line up, that's great. If for some reason this was also an int, then our editors would immediately say, whoa, there's 2 things wrong right straight away, right, because of the typing. Ints don't have strips, and you're passing it to this function that says it takes a string here, but it's not, right? So this is pretty cool that we have these editors giving us all the support. And the fact that if we go over here, we need to import this lib thing from there. If we go and call this, it says it's going to take, let's say, 42 and trolls all the way down. Something like that, right? So the fact that the editor knows what type it is, it gives us autocomplete on all these things, right? And sometimes it can guess. But when you express, like, what is the return type, like this one says, I believe it returns a string. So it knows already what we can do to the return value of it, right? So it keeps you out of the docs. It just keeps you typing less, and it keeps you flowing well. So what is the amazing thing? Well, here's the amazing thing. I only have 3 very small projects, or small files here. But this works on an unbounded set of files, right? So I can go over here, and I can say run code inspection on the whole project, which is probably what it'd be, but because this is like a little subset. I'll just say this directory, right? But you could run this on, 50,000 lines of Python and ask, how are we doing? Now, right now, what it's going to tell you is you have an unused variable, you have a long line, you have all that crap. Like, okay, I don't want that. So what we can do is we can go in here, and I can say, I would like to duplicate this and give it a name, typing checks. And then I would go over here and uncheck. I'm just going to uncheck the Python one because the other ones don't really apply. Python, you got to be in there somewhere. Python, boom, uncheck. No, uncheck. And then search for type. And then go find Python again, collapse it, check them, turn it back. So now if we go down to Python, you can see that it's not all selected, just the stuff about like incompatible stub package or incorrect type or protocol and usages don't match. And there's a few other things like that one I should probably turn on. Like you be more careful than doing this during a live talk. But if I say that, I can say now analyze and did I not do it enough? Let's see. There we go. So come over here and it'll say, hey, there's 2 problems in your code. And they actually were in not my library directly, but that I was working on now, but in the library that my library was using, there's a problem with the way of the types. And so down here you can see like straight away. So you can ask like not just, do I see on my screen something with no squiggles, but how is the whole project doing? Like how's everything hanging together? You could do MyPy, but MyPy is kind of intense, so you might want to just go, hey editor, just analyze all 20,000 files or lines and see how they hang together. And I think that's kind of amazing, right? I think that's a lot of, you don't have to look at it, you don't have to like open anything, just go tell me how I'm doing. I'm not doing well, by the way, on this one. It's not working out. I need to fix these things. But you can go over here and you can see, sure enough, I said it's an int and then I said it's out of bounds. Probably not great. It'll probably still run though. Let's see. Sure enough, because I guess I didn't print this, did I? But this might be something huge. I might regret printing this. No. I think it's just an empty string or something. But anyway, that's part of the gradual bit, or the ignored bit as well, right? It's like it's wrong, but it's not that wrong. So let's just keep going. Okay, so that's amazing thing 1. Is you can use your editors not just to help you write code or understand what's in front of you correctly, but you can ask it about entire projects, like, hey, how's it going? And by the way, I don't know if this works on VS Code. Does anybody know if there's something equivalent to this on VS Code that's like, I'm not aware of it, but.
There's extensions that do it, but I don't know if it's like a default thing.
Will it run across like the entire project, not just your?
There's extensions that do it, but I don't know if it's like a.
I don't think the default one, the built-in one. I don't think that PyLance and stuff will.
If you're using VS Code for Python, you have a Python extension installed, and I think that does it. But I'm not
It does it for the open file,
Yeah,
but
I'm not
yeah.
sure it does it for the whole
Yeah. I don't. The thing I'm asking about is if it'll do it for like your whole project, and I'm not sure about that either. Yeah. Thank you. Okay, I think that's pretty amazing. Now, you saw that it was wrong, but we didn't seem to care too much about it, right? What if you care? What if you want to know? Actually, I put the typing there, and I want you. All right, folks. We'll just round this out with what was Benoit B. Mandelbrot's middle name? Benoit B. Mandelbrot. All right. Ooh, into the fractal we go. All right. Bear type. Shall we resume with bear type? Because bear type actually may be my very favorite thing. It's number 2 on the awesome list, but it might actually be the most awesome. So here's the deal. You've gone and put these types onto your classes or your functions or wherever, and you would like to be able to at least some of the time know, not by running MyPy or something else, but if ever they are misused, okay? So this is actually such a cool page. I got to read you just the introduction. Here's the episode with Joe. I was going to pull it up, but then we got distracted. Okay, so if they kind of bury the lead here, and they have awesome stuff like raise the paw of the bear. But down here, if you wonder what it is, it says bear type brings Rust and C++ inspired zero-cost abstractions into the lawless world of dynamically typed Python by enforcing type safety at the granular level of functions and methods against type hints standardized by the Python community in O of 1 non-amortized worst-case time with negligible constant factors performance. Woo! Which was just a joke, of course, but it is pretty awesome. And so here's what you do. Let's go to this thing, and let's look at an example. So I've got this, I know what you call it. It's not really an app. It's just like a silly example. But I've created a class so we can show whether it works, test whether it works on our own custom types, and we can do some stuff with numbers here. So we have math with numbers where we return some things. And this point is very useless because it's one-dimensional. This could be a number, but whatever. It has one value, so we can do math on points. Now, if I come over here and say x equals input of enter a number, like that, and we duplicate it and we say y is enter another number, and then let's just try to call math on numbers with x and y. What's going to happen? Well, PyCharm is going to say, because editors are awesome, we expected a float, but we got a string. And I'm not sure if you all are familiar, but there's this thing called the numeric tower in Python typing, where you can have, if you want to say, like one thing I could do is I could say down here, this takes a float or an int. That's not an int. Or an int, like this, right? But you never have to do that because the numeric tower says if it's a float type, that means it could be an int or a float. It could even be a complex, which means it's complex, float, or int, and so on, right? So int, float, whatever, it's all good. We're going to use int here. Like this. And now, with the right parentheses in place, everybody's happy, right? Looks like it works. And let's go ahead and do this as well on the points. Just so we already have this in place, we'll have a point of x here, and a point of y. Does it work? We don't know. It's a mystery. 42 and 10. Didn't crash, so it must have worked. I'm going to call it good. We should probably print these out. It's like Unix. No response, it means it's good. Print. Print. Run again. 42 and 100. Hey, it works. Of course, 5,034. We knew that. But what if we had made this mistake that we had up here before, where it looked like that? But we didn't do the int thing, right? I just did this. Well, suppose you don't know that this is happening, or somebody's using an editor that doesn't actually track these or whatever. We would like to know at runtime, no, you can't pass a string here. It says it takes an int. So that's where this bear type thing comes in. Bear type, and you just decorate it at the right end, like that. And you just go down here, and you run it, and you import it. And you run it, and you try. It says, okay, 42. Remember, it's not converting these, so it should crash. And has raised the paw. It says right here it has roared. There's a lot of fun in this one. So the bear type has roared here. And it says the parameter x, which is quote 42 as in a string, violates the type hint where it's a float because it's a string. That's pretty cool, right? It's probably dreadfully slow and should never be done. But remember the highfalutin paragraph I read you at the bottom. So I created an example. I said, well, let's see just how bad is it. Here's an example that I tried to simulate doing real things. Like it's kind of computationally expensive to call the function, but not terribly. Like I don't want to time how long is it to create a number or something stupid. So it kind of like loops around and does a few things like surprisingly fast. So we're gonna, I think it's like around 400 times. We're gonna do a bunch of these things like take a bunch of square roots or multiply this as a common sentence times 100 many times, put it into a list, 10,000 times actually, so a lot. So if we run this one, it takes about 983 seconds. Let's run it a few times to get some numbers. It's very scientific. 992, 997, 987. And I went down here and I put bear type checking on all those functions that are called. We run it again, and it's adding about 20 milliseconds, something like that. Quick math, maybe 15. Not very much if what you want is to have runtime type checking. But what's more interesting, I was sitting here this morning before I came down to San Francisco at the hotel. I was just outside of town, eating some breakfast, thinking, well, what I could do is explain to you how to make this a little bit more awesome, a little low effort. I'm like, Michael, don't be wimp. Come on, do it. Just do it. Let's write the decorator called barely typed for bear typed. And with barely typed, you can choose whether or not to apply bear type at runtime dynamically, but leave your code the same. So what you can do is we can come over here and we can have a barely typed function. I'll explain it in a minute, but let's just see this bad boy in action, then we'll talk about it. So this one could be barely typed. We've got to import that. All right, now you would never do this, but it prints out whether it does runtime checking or no runtime checking, okay? So let's go back to our example, and let's do it right, not wrong. So if we run this, now we can say come back here, say 42 and 1, and this one, X. Oh, what's going on with it? Why is it unhappy about this? It's an int, not a float. Fine, I'm going to say it's an int, but that seems wrong. I told you about the numeric tower. 42 and 1. So see, it's doing runtime checking because the barely typed by default expects you to have that. But if you go over here, I'm going to need to import this as well. And we turn it off. This decorator right here, I didn't write it this way, but it could literally just return the same function and not even have a wrapper if you turn it off. So it is indistinguishable from a bytecode perspective of the one without it. So 1 and 2. No runtime type checking, right? So, I mean, if I can do this over breakfast, just because I was curious, surely, right? Like here we could just return the function directly and off it goes, right? Not even have this wrapper if you wanted. So basically it just says, hey, look, we're going to wrap this function, but if you want to do type checking, also wrap it in bear typed. Otherwise, just call it directly, right? So you can have this and just dynamically turn it off. Like you could say, we're going to do some really deep testing on our code, turn on this checking to make sure what we said was happening is happening, and then turn it off before we ship it to production. Or not, you know, depending on how you're feeling. So bear type, pretty cool. What do y'all think? Yeah? That's a good one. Okay, ducks. Back to ducks. Could ducks be the amazing third thing? Let me tell you something that may surprise you. I'm going to show you how to have statically typed duck typing. Yes, ducks can be amazing. So first of all, let's do like a thought experiment here in maybe what could be called like the follies or misadventures of object-oriented programming. So we have a vehicle, and we want to do vehicle things with it, drive it around, turn it on, things like that. And we want to model different things that can live in our world of objects with vehicles. So we're going to make a motorcycle. Motorcycles are vehicles. You get in them, you turn them on, you drive them around. Cars, probably what you first had in mind. So that's cool. This has been working out super well, so we do a lot of it. And we go like, you know what? we're going to really just make sure that this type hierarchy expresses that these vehicles have transmissions, engines, brakes, throttles, keys, etc. And we have an electric motorcycle. Are those motorcycles? Are they vehicles? Sure. Weird engine. But okay, whatever. Off-road motorcycles, are they vehicles? Yes. Who says vehicles have to go on the road? That's not in Michael's definition of vehicle anyway. However, do off-road motorcycles have keys? Sometimes. Motocross bikes don't. Enduro bikes, they don't think so. But certain bikes do. Adventure bikes do. So should it have keys? I don't know. And electrical motorcycles, do they have transmissions? Probably not. Like, it's probably just like electric drive straight to the sprocket. Maybe there's a changing of the speed ratio. But other than that, no, not really. Whatever, it's working. Keep going. Let's have one of these crazy things, like these Boston Dynamic robots. You could probably ride that thing around, and who says you have to be on a vehicle anyway to actually, geez, this thing does not want to stay. Who says you got to be on it for it actually to work, for it to be a vehicle, right? So I claim that this could be a vehicle as well, but does it have an engine? I don't know. It probably has 4 engines, maybe one for each leg or something. Does it have a throttle? Maybe it's robot brain. I don't know, right? So this is not working out. And if we did this with duck typing and but in order to like use the robot, we have to say it's a vehicle so it matches the type where we said the thing that we work with is a vehicle, right? Like, our duck is looking better again. Bring back the duck. Come on, it's a new slogan. So maybe we just want to start the vehicle, turn it in a direction, and accelerate. Could we just do that? How about a better motorcycle? Huh? Can we build something that like is not so tortured as what we had there? All right. So let's go over here. This stuff maybe you've heard of, maybe you haven't. Have you heard of protocols, like in the sense that you've actually used them other than just hearing the word? So in other languages, you're right on. In other languages, you've heard of interfaces, and interfaces are kind of like protocols, but they're not like protocols either at all. So protocols lets you specify an abstract concept of the attributes some class or other thing must have. So for example, if we say something should be able to turn on, turns towards, and accelerate, we will just say a class derivable, or whatever, is a protocol. We import it from typing. And then we just start writing out functions or properties or whatever. And what do we want to do? We want to say turn on. And then instead of writing implementation, you say ... I don't care. Just keep going. And down here I have my motorcycle again. And I'm just going to, for the sake of time, rob one of them. Let's do it like this. And I'll take one of them. Okay. Okay, so here's a way to say, very much in a duck typing way, like, we're going to have this function that's going to take this object, we don't know what it is, but we need to be able to call turn on, turn towards, and accelerate, right? So in the duck typing sense, if it doesn't crash, then it must be one of those vehicles, right? But we want to do this in static typing, so we're going to say, instead of typing.any or something terrible here, we're going to say drivable, and that's going to tell you that anything that gets used here must have those features. And I must have typed on something a little, oh, this needs to express that it returns a bool, I think, here to match without the semicolon. Yeah. So you might have noticed there was a little error right here, and that's super interesting. Because if you look at our motorcycle here, what's its base class? None. Object. Wait, none. No. What are them? So whatever it is, it's not drivable. There's nowhere where we've expressed like an interface, like it derives from this. But the Python typing thing says, look, if you say it takes one of them, and it has the features that would, if you made it derive from it, it would have been one of them, we're good, like a duck. But watch this. If it doesn't, come here. If like for some reason it doesn't have that, all of a sudden you get an error, and it says we expected it drivable. But I just changed the features of that class. I didn't like change its base class or any weird thing like that, right? Isn't that cool? So you can say, look, I want to express in a much more concise way what the duck wants, but I want to be able to test against that with typing. So it's a really nice way to apply it, like a huge code base without touching hardly anything, because you don't change your classes. You just write the expectations down as a protocol. So I think that's pretty awesome. So now we could say, well, motorcycles, and they kind of break off like that with this automobile, and there's this weird robot thing, but long as they all have the attributes of this protocol, you're good to go, and you have your strong typing still. So that's pretty excellent. Pydantic. Is Pydantic amazing? Yes, but it's too old to be on this list. So let me show you something really cool with Pydantic. So Pydantic, let's go over here and look at, that is not what I want. I thought I would autocomplete. Weather.talk, python.fm. So I built this for my different classes and stuff because you need a stable API. I've learned over and over painfully. And what it will do is it'll let you put in a location, and it'll tell you the real weather in real time for that location. But please don't try to build a weather app on it. It has a very low rate limiting on it, and so I don't recommend it. Get some other API. But it has like this complicated thing. Like you see there's weather, and then there's this nested object that's going to have to be some other thing that's going to be a sub-Pydantic model if you want to model this. But watch this. So we're going to go over here, and we're going to switch to this section. I copied this over in case the internet at the conference didn't work. I know that never happens, but just in case. So check this out. Let's go to this place. Did I pull up? Oh, whatever. I'll just type it again. JSON to Pydantic. And over here, whatever you can zoom to the big enough size, whatever you put here as JSON, it will try to model that. So you can see foo is an int and a bar. And if we type in age is 70 or whatever, see it as age as an int. So we take our stuff and we paste it in there. It'll write all the different classes and combine them together in Pydantic so that we can parse all that data. What are you doing? From here, all right? So I'm just going to copy. And then we can go down here and just say, check out all this stuff it did. It said, okay, there's this thing in the middle somewhere called weather. It had a description and a category. This was a wind. Sometimes if things are nullable or null, you've got to change it a little bit. But we'll just call this weather model. And all I did is take the JSON output of there. And we're going to need to get the data, which actually had that here. No, I had that here. And somewhere we'll just say data equals paste format like this. We can just explode out the dictionary, and we can just print the weather. Look at that right there. Isn't that awesome? So, and this could even be something in like quotes, and it'll automatically parse it just like Pydantic does, right? Because it's just Pydantic. It's just really complicated Pydantic, but I didn't have to write it. Now, I accidentally hit the wrong button and closed that, but it comes back. Over here at the bottom, you can see it is actually based on a way harder to use data model-code-generator that you set up a TOML file to explain how you want to parse it. Just go to JSON to Pydantic, paste it in there, you're good to go. Pretty awesome, okay? So if you want to do really neat things with Pydantic, automatically generating Pydantic classes is certainly one of them. All right, last one. This one is kind of last minute. I was on the edge, on the border of like, what's going to be the last one? This monkey type was the runner-up for this spot. And monkey type is run it against your program. It observes, kind of like bear type, what types were exchanged, and it will given untyped Python code, it will generate the typed version for you. So if you don't want to write it, you just hit it with the monkey type, and then boom, it'll give you, it actually doesn't change your code, it gives you stub files, so you can still get typing without, but then I would just import them. So, but this is what I put for number 5 is message spec. Have you all heard of this? I hadn't either until I talked to the Lightstar guys, and they're like, oh, yeah, we also support Pydantic, but we do message spec, and it's amazing because it's so flexible and fast. It's a fast, emphasis with the italics there, serialization and validation library. You should think kind of like Pydantic, but for JSON, message pack, YAML, and TOML. And it supports zero-cost schema validation, and it has a type kind of like Pydantic classes. But if you look at the performance, you'll find it's quite a bit faster, right? A lot faster. So let's just look really quickly. It's pretty new to me, so I don't know a whole ton about it. But in Pydantic, we come up with a class. It has type information on its fields. It drives some base model. Here, we come up with a class that has type information on it, but it drives some message spec.struct. And then what you do is you just do the same thing. You just say, decode this into a class. Actually, is that the right one? Yeah. I think you might need to say, is it type? Type equals, what we call it up here. I think you might need to do that. Is that right? No? Maybe. Anyway, basically use it in a real similar way, right? Very similar, but it has like different binary formats and other file formats it can go to and from. So one more new thing. If Pydantic was new, Pydantic would be the amazing thing. But since everyone knows about it, I wanted to bring something different. All right, so I'm also writing a 5-hour course in this, so people can check that out at talkpython.fm/courses. If you want, some of these ideas are from that course. But yeah, mostly I just thank you for being here, and thanks for all the thoughts, and hopefully you enjoyed it. Hopefully you learned something. Yeah. And thank you for standing through the intermission. I noticed what the problem is. That.
Okay, so that was Michael Kennedy. Everyone, a round of applause. That's great. So we're going to move on to, anyone have any questions? Oh, yeah.
Thanks, Michael. That was great. I got a question on bear typing versus like type check, type guard, and type check.
Yes.
Can you you compare and contrast those, or are they kind of the same thing? Or?
I don't have enough experience with type guard to say. I'm sorry, but yeah. Yeah. Yeah, like this looks really nice to me in that it's super low overhead and you can turn it off through decorators. I also didn't point out that there was, I kind of skimmed over in the bear type thing up here. They do point out at the very beginning that you can just apply it to your entire code base in one line, 2 lines. I mean, maybe a semicolon would be good. Then you can do one line. But yeah, basically you can say anything that has type annotations, check it. Or you can be more particular like I was. But yeah, sorry, I know about type guard, but I don't know enough to compare them.
Yeah, that's probably the big difference. I don't think they have that. I don't know that.
Yeah, yeah.
Any other questions? No one else? Okay, that's all for today with Michael Kennedy. Thank you, Michael.
Thank you.
Okay, we're already running late.